finite but boundless.
The three-space embedded in the four-space manifold is finite but boundless, but what that manifold is embedded in is another question altogether.
How much of it is a psychological, mental imagination just going to all those dimensions, and how much is the physical reality of the...
That is a very, very good question. Modern string theory is up to about 11 or more dimensions now. Theravada Buddhism has been preaching for almost 3,000 years that there's 71 dimensions. So people like us who teach physics at a university say, keep on going, you're getting close.
Yeah.
Modern string theories feel that some of those 11 dimensions are actually about the size of a walnut, and there's some laboratory evidence now backing this up. Gravity is one of them.
Gravity.
Yes.
Gravity seems like plays a central role in almost all of the physics.
So, and it's all the mathematics and everything points to the fact that it plays a role much greater than just here.
Yeah.
It extends out into there. And here, at least, it's at a dimension about the size of a walnut. So, although it travels at the speed of light, it does not have very far to go. This way gives momentum. Mm-hmm. Your camera has the mass of the universe holding it in place.
Like your eyes.
Yeah, the property of momentum is an artifact of the sum total of all the matter in the universe.
One more time. What is the sum total of all the matters in the universe? The gravity?
Momentum.
Momentum.
That is what
is the sum total of all of the matters in the universe.
This is what keeps a gyroscope aligned.
Okay.
So you can point it in a given direction at a star and the Earth can turn, and 6 hours later there's a completely different star up, but your gyroscope is still pointing to that star you originally wound it up to. How can this be? How does that little wheel inside the vacuum chamber say, no, you can't even see that star it's pointing at. How does it know? How does that information get in there? That is the sum total of the mass of the universe acting directly on that little spinning wheel.
Is a central kind of singularity, or what they call the omega point, that has that, that we don't know what it is, but some sort of a central singularity, or the Big Bang, or whatever. I don't really know.
Modern physicists are a little bit uneasy with the singularity. If you think about it, enough matter can overpower and collapse into a black hole. And yet the Big Bang was all the matter and all the energy that ever was and ever will be expanding outwards. How can it do that? And in fact, it cannot. So what expanded outward was time and space, which is actually stronger than matter. So time and space is stronger than a black hole. So modern physicists take that view that time and space is expanding. So the omega point would be the point where expansion stops and turns back into contraction. And modern views is this is probably not the case. And it will keep expanding forever. Eventually the fabric gets so thin that it cannot support even a proton. So the integral death of the universe is when space-time cannot support matter. So matter ceases to exist.
And you said that the black hole doesn't have the characteristic or attribute of time and space?
It has the attributes of matter, the angular momentum. A black hole is a big flywheel, so it knows about all the other matter in the universe. But it is not more powerful than space and time. Space and time, if their view is true that it is continuing to stretch, will eventually tear apart all black holes.
Oh, it will tear apart all the black holes. So it has more power than the black hole then?
It has to, otherwise the universe could not have created itself. the act of creation would have created a black hole, would have all fallen.
And the black hole also is a very high kind of gravity force, or is it not?
Yes, it is gravity overcoming the local piece of space-time. It just winds it up into a knot.
I see.
All space-time is believed to be curved. They can actually measure this curvature. Right here, the curvature is about 93 million miles, the radius, which is a fairly tight curve. It's only the fact that it happens in force space can you have such tight curvature everywhere and still not have it.
But they say that when objects fall into the black hole, then they somehow go faster than the speed of light. And then before going to the process of kind of total annihilation, they leave an image on the surface of the black hole and kind of like a holographic things that
is what they believe, and to some extent they hope is the case. The event horizon is a point at which, if you're orbiting the black hole, your speed goes faster and faster as you get to lower orbit. The event horizon is where, on the other side, your rate you would have to travel in orbit would be faster than the speed of light.
And there's no way out, right?
Not under existing theory, no. But in every era, scientists get so full of themselves that they really can explain everything, understand everything, and Zen Buddhists kind of smile at them, yeah, deja vu all over again.
And dark matters and dark energy, how do they connect or relate to any of this?
They are the most important force in the universe which holds the curvature in place. The bright matter is actually the minority of matter. Bright matter is only responsible for about half of the orbital speed of the suns in our galaxy.
Those are the visible world that we can see with telescope
exactly.
or whatever.
The visible matter causes things to orbit only half as fast. It's like the sun. We can measure the mass of the sun, but the mass of the galaxy is only half of what has been measured, and half of what...
Half of what is measured.
Yes, and half of what is necessary to keep the stars orbiting at the speed they do. The rest is dark matter.
And we don't know much about what it is, because it just there's nothing to penetrate to see what it is.
We have some theories. There's things like neutrinos, which do not interact strongly with matter at all. They travel right through the Earth with almost no interaction, but that is still bright matter. The dark matter is the same thing, only more so. It just absolutely can, except with gravity, cannot and will not interact with this universe.
And the laws of the physics that exist in those universes, we don't really know much about. I mean, those dimensions that you talk about could exist in those places, but we don't really know about it.
It's very presumptuous to say we know of those things. What it is analogous to, you see around you, is a shadow. Okay, a sphere in 3 space. When we make a shadow on the 2 space, it shows as a circle. So here in our 3 space, we have a sphere. That is a shadow of a hypersphere at a higher level, and as you go up dimensions, this continues. So,
moon still up on the horizon. Clear, beautiful blue sky. I'm surrounded by all this beautiful sculpture, horses, lions, temples, flowers, birds, bricks, color, moon, trees, Buddha, lotus, dogs. Oh my Lord, what else could I ask for? What else I could wish for? Being alive and still healthy. I'm so happy. I'm so grateful. I am so fortunate.